about the synchronous machine. Last class we discussed the idea of this problem يا شباب. تمام؟ 3 phase 250 horsepower 2300 volt, and we agreed that 250 horsepower. What is this value يا شباب؟
748 multiplied by 250.
Sorry?
Just a minute.
Again, what is the meaning of 250 horsepower? What is this value? It indicates what here?
The power.
Capacity.
Power. Which power? Is it output or input?
The input.
Output power. So this is here P output of the machine. يعني which يعني from the يعني understanding here, it is working as motor now, تمام? Because it's given as a mechanical load. And all of time mechanical loads are given in horsepower. طبعا 2300 volts, so this is line to line volt, 60 hertz, star connected, non-salient, it means cylindrical. Rotor synchronous motor has a synchronous reactance of 11 ohms per phase. When it draws 165.8 kilowatt, so this is the power input now because it draws, تمام? So this is considered as P input. The power angle is 15 electrical degrees. طب by the way, is it rated or not يا شباب? Here, when it draws كذا, is it mean this value is rated or not?
No.
No, بالظبط. يعني it's any operating point for the machine. So we have the value of power, and also we have the value of power angle. So P is given and delta is given. Neglect ohmic losses, so resistance is 0. Determine the excitation voltage per phase. يعني let's يعني solve it in the Word file here. So we have now example or problem number 2. We need the value of EF, where B is given and delta is already given. يعني I would like to solve it in numbers with you شباب, يعني to understand how we can substitute even in relations. يعني here we have power of 165.8 and 15 degree delta. So P equals 165.8 kilowatts and delta is 15 degree. How we can get EF يا شباب?
VT minus
VT EF equals, this is motor now يا شباب, so we can say VT minus JIAXS. صح كده? Do we have
Yes.
IA now?
From the power.
From the power, so we can get the current from the power. We have now the relation of power, which is or we can use and we can say P is given, so we can say P equals 3 V phase I phase power factor. طب do we have power factor?
We can get
we don't
it.
have power factor يا شباب, so we cannot use the EF relation like that, because in order to get IA we need the magnitude and angle of current, and also
Yes.
there is no power factor given here, so we cannot use this equation anymore. طب what we can do, we know the relation of power itself, صح? So we can
Yes.
say electrical power of the machine P equals 3 EF phase V terminal phase over XS multiplied by sine delta. صح يا شباب? We have all of data here except E. We need E. So we can say now EF equals P multiplied by XS multiplied by sine, divided by V terminal 3 V terminal sine delta. تمام? So we can substitute now. يعني let's substitute together يا شباب. P equals 165.8 multiplied by 10 to power 3. صح كده؟ Multiplied by X. X was given XS equals 11 ohm. So it's multiplied by 11 over 3 V terminal sine delta. يبقى 3 multiplied by V terminal. V terminal was given as 3300. صح يا شباب؟ V terminal, sorry. V terminal was given, 2300. This is line to line يا شباب, صح ولا غلط؟
Yes.
So we can say now, instead of 3 multiplied by, we can say square root of 3 multiplied by 2300 صح؟ multiplied by sine ايه 15 degrees. بالشكل ده يا شباب if we calculate EF we can get the exact value. طيب the value we obtained now يا شباب is it phase or line؟
line.
احنا استخدمناها منين؟
phase
Take
ده.
care. It's phase value. Here
Okay.
the relation 3 E phase V phase صح؟ يبقى E here is phase value. يا شباب
Yes.
اتفضل.
Why we didn't say that sign delta should be negative?
Is it going to be different?
Yes.
عوض كده. Sine 15, sine minus 15. What will be the difference now?
تكون بس minus.
It will be in minus. Is it logic?
Yeah, okay.
It's not logic. هي الفكرة يا شباب يعني in this relation we use only the magnitude of the angle. تمام؟ يعني because of the derivation we use delta here as absolute value. We don't care about the sign here. However, when you calculate vectors, when you calculate any vector equation like that, EF equal VT minus, here we have to consider the angle sign. However, in this relation, you shouldn't consider the sign. صح? It's just real part. يعني all of calculations here are based on absolute values, not the angle sign. Okay? طيب. احنا قلنا يا شباب في جزء من المسألة ده من المسألة دي عايزكم تحلوها صح ولا غلط؟
Yes.
Which part? To find the supply line current. يعني I think we already get the supply current. صح؟ يعني I think number D.
Yes, number D 3.
طيب يعني let's يعني continue discussing it together. يعني I expect from you now يعني you are familiar how to calculate يعني all of the parts of the problem. Determine the supply line current يا شباب. طيب يعني نقول بالأسماء ولا حد تاني يتكلم معانا يا شباب؟ يلا نمشي بالأسماء أفضل. خلينا نبدأ برضا.
Yes, sir.
Please رضا. يلا continue with me. Solve number B.
Now that we calculated
By the way, before starting رضا يعني please شباب يعني when you join me in solving problems you may have some mistakes. This is يعني very good. Why? Because when I solve you will take the answer. This is the answer. You are يعني you are ايه يعني يعني انت مطمن ان دي الاجابه الصح. لا لكن لو انت بتحل او حد منكم حل وفي خطا ظهر دي هتبقى يعني very valuable بالنسبه لكم علشان هتوضح يعني الاخطاء اللي انتوا بتقعوا فيها في الامتحان. فعشان كده مفيش مشكله خالص انك تخطأ في الحل في الكلاس. الخطأ في الاكزام هو اللي بقى مشكله. لكن هنا يعني the class is made for your training. فعشان كده يعني I prefer you to join me in answering any problem. وده برضو بيديني انطباع يعني عن الايه المستوى العام بالنسبه للكلاس. فيا ريت الناس تشارك معايا. اتفضل يا رضا.
we can use the relation it's gonna EF equal VT minus JXI.
Here. So we can say now here we need to calculate current. So we can say I from the relation here we have from here we can say
IA equal VT
minus
EF over JX.
JXS. Here we have to use the angle sign. صح ولا غلط?
Yes.
Yes.
So we can say now what's the value of V terminal?
V terminal 2000 divided by root of 3.
Exactly. At angle 0 minus EF. We obtain the value of EF at angle. So the value of absolute value of EF will obtain. At which angle يا شباب؟
minus 50.
Minus. We have to consider the sign here. تمام. كمل يا رضا اتفضل.
Over JX. We have
XS. We have it. It's 11 ohm. تمام. The answer of this part يا شباب will be it's not given here يعني we can calculate it easily. طيب number C determine the supply power factor. طبعا supply power factor is nothing but the cosine angle of current. تمام؟ يعني if we calculated this part here. حد معاه كالكوليتور يحسب معانا يا شباب؟ يا شباب حد معاه كالكوليتور يقدر يحسب معانا؟
Calculate the EF now.
ها what is the value? EF we got EF we need to calculate EF in the beginning. طيب نجيبها مع بعض عشان الفاليوز تبقى ايه؟
1021.25
EF تاني EF equals
1021.25
1021
1021.25
0.25 volt. جميل. So when substituting here يا شباب what will be the value of current?
I got different. I got.
طيب
the
خليني انا احسبها معاك.
I get different answer which is 1768.
طيب خلينا احسبها معاكم. multiplied by 11 over 2300 multiplied by square root of 3 multiplied by sine 15. So the answer is 1768. تمام؟ 1768.9. So this is EF يا شباب. When we substitute here, okay?
We get 54 angle 39.
minus angle minus 15 over 11J. So the current is 54, صح?
Yes.
0.13 angle
39.
39.7. It's in positive. So this means يا شباب the power factor here is lagging or leading?
Leading.
Exactly. So we can say now power factor equal cosine this angle 39.7. It's equal to 2.77 approximately leading. جميل. طب لو سألتك سؤال نظري هنا. Is it logic to have leading power factor for motor? ها الإجابة تبقى إيه يا شباب؟ Now this is motor, which means it consists of inductance and resistances. Can we have leading power factor?
When it's under excited.
Exactly. This is synchronous motor. Synchronous motor can work at any power factor. Can be leading, can be unity power factor or lagging. It's possible. تمام؟ So يعني it's very important شباب to note that يعني power factor can be changed for synchronous motors. طيب. الأسئلة دي بتبقى مهمة جدا يا شباب في الام سي كيو. يعني الام سي كيو دايما بتبقى conceptual questions. تمام؟ وفي ناس كتير قوي بتقع فيها بسبب يعني بعض الحاجات الرومانسيه او في بيزكس مش موجوده او كده. فلازم الناس تفهم كويس جدا الموضوع ده. طيب السؤال اللي بعده يا شباب. determine the supply power خلاص. if the mechanical load is thrown off which means P out equal 0. P out or P input يا شباب؟
With the losses and the input will be 0.
جميل. but the meaning of mechanical load is thrown off this means P out. صح كده؟
Yes.
تمام. and all losses become negligible. so كمان اللosses يعني neglected. so we can say now P input equals 0. المطلوب رقم 1 determine the new line current and supply power factor. We need to calculate the current and power factor. طب now يا شباب the question is when the load is thrown off is it going to change the value of excitation or not? The field current is it going to be changed or not?
The excitation no. Voltage.
So EF will be constant. صح ولا غلط يا شباب؟
Yes.
So the value that will be changed here is the value of current. So we can expect that we need now to calculate the new line current and supply power factor. So we can say now for part number D, power N equal 0. EF in this case is similar to what we have calculated before, which is 17 something, I believe. أيوة 1768.9 volt. So we have EF and P is 0. طب what is the power angle now يا شباب؟
0.
Why? Because we said B input equals 0, صح?
Yes.
So delta equals 0. So we know the value of EF and delta. So mathematically, we can substitute now in the same equation. We can say now IA equals V terminal minus EF over JXS. صح ولا غلط شباب؟
Yes.
So it's now 2300 over square root of 3. حد يحسب معايا يا شباب؟ Angle 0 minus the same value of EF, which is 1768.9 angle 0 over JXS, which is J11. What will be the value of current يا شباب؟
J.
49 angle 90.
Like 90.
Angle will be 90 and magnitude is
40.1.
40.1.
0.1.
Okay, so now this is the current now, and the angle is 90 degrees. 90 degrees, it means it's now leading. صح ولا غلط شباب؟ So power factor now, we can say power factor equals 0. كده كفاية يا شباب؟ ولا we have to specify the type of power factor?
Leading.
So we have to specify. So value is not enough. We have to say it's leading. طبعا يعني only the unity value is enough, because unity يعني it's not lagging or leading. طيب, this is number 1. Number 2 يا شباب, draw the phasor diagram for this condition. طبعا phasor diagram يعني we discussed this part يعني recently. If we would like to draw the phasor diagram here, it's nothing but the synchronous capacitor case, which is like that. This is V terminal. Okay, and you have IA will be in phase with V terminal, so IA will be like that. Okay, and this IA is leading by 90 degrees. يعني مش عايزة تتظبط 90 بس يعني هي المفروض 90 degrees شباب. تقريبا عايزة تتمسح وترسم هنا عشان ما تبقاش ايه confusing. يعني يا ريت يا شباب دايما نحاول ان احنا نرسم الفيزور دايجرام يكون لوجيك، الانجلز بالذات. ماشي. So IA is leading by 90 degrees. If you would like now to substitute in the equation, substitute and plot the value of EF. You will find that EF will be represented like that. طبعا يعني EF and V terminal should be in phase. ماشي شباب. So this is here. EF. So this is EF. This is IA. This is V terminal, and you know the relation EF equals V terminal minus JIAXS. V terminal is this vector. JIA, it means in that direction, so minus J will be in that direction. So minus JIAXS considered as this A part. This is minus JIA multiplied by XS. طيب. Number 3. By what percent should the field current if be changed to minimize the line current؟ يعني نغير يا شباب how much field current should be changed in order to minimize the line current. يعني now we get the line current here is 40 amps. And we, as we could see, the power factor here is leading, 0 leading. By what percent the value of current will be minimum? By what percent change in EF in order to achieve minimum current يا شباب؟ ها احنا قلنا دي هتحلوها. مين فكر فيها يا شباب يقولها لنا؟
Yes, I think that when the power factor is unity.
مين الأول بس؟ مين الأول اللي بيتكلم معايا؟ عادل. تمام. We have only one عادل محمد، صح كده؟
Yes.
اوكي عادل اتفضل.
Okay, when the power factor is unity and there are no losses and no load, so the current has to be 0.
Exactly. This is very good. So here يا شباب, because we don't have any power equals 0. طبعا we mean electrical power for the motor, which is Bm. Power equals 0. This means delta has to be 0. And you know the relation of power equals also V terminal IA multiplied by power factor. And you know the expression of minimum current means power factor is ايه يا شباب؟ Unity, exactly. طب we have V terminal, it already has a value. And we have power factor is unity and P is 0, so this means current has to be 0. صح كده يا شباب؟ So the solution of this part, IA equals 0. This is the minimum current. Type for IA equals 0, what will be the change in excitation? This means the excitation now will be the same as V terminal. صح ولا غلط?
Yes.
So we now, so for the case here, we have EF equal, say EF2 equals V terminal. So we can say now change in EF شباب as EF2 minus EF in case number 1 over EF in case number 1. And if you need it in percent, so we have to multiply by 100% like that. So we can say easily now EF in case number 2, which is V terminal, so it's 2300 over square root of 3 minus, this is as absolute only شباب, huh? Without angles, minus EF in case number 1, which was 1768 over value of EF1, which is 1768. And we should multiply by 100. ها شباب حد حسبها؟
24.9%.
24 positive or negative?
Negative. But it's positive because we have it under or inside the absolute.
لا we don't need absolute here because the sign is يعني ايه يعني will refer to something. ها يعني يعني this value is greater than that value, صح ولا غلط؟
Negative.
So it's 24 point something.
0.9.
0.9 جميل. So this means what يا شباب? The minus sign here means what?
We decrease it.
Exactly. It means reduction in excitation, and this is logic. Because if the machine is working, at over excitation, at leading power factor, and you need to make it as unity power factor, you should reduce your excitation. So we need a reduction. So the conclusion, what for how much the flux or the excitation should be changed, we should say we should reduce the excitation by 25, almost 25% to get minimum armature current. Okay, شباب? So this will be the right answer of this A part. واضحة شباب؟
Doctor.
تفضل.
And if we asked for like maximize the current?
Maximizing current has no specific point. However, we can say the maximization here means the operation at maximum power. But this is not يعني ايه appreciated. يعني no one can work with maximum power. تمام؟ يعني this is not an operating point. يعني so the logic here to minimize, not to maximize. Okay?
Okay.
طيب Problem number 3 يا شباب, we said it's almost circuit problem. A factory takes 600 kilovolt ampere at lagging power factor of 0.6 ampere. Sorry, at lagging power factor of 0.6. A synchronous motor is to be installed to raise the power factor to 0.9 lagging. So the desired power factor is 0.9. When the motor is taking 200 kilowatts, calculate the corresponding apparent power in kVA taken by the motor and the power factor at which it operates. حليتوا المسألة دي يا شباب؟ ولا نحلها مع بعض؟
solve it together.
طيب اوكي. Let's solve this problem also together. يعني by the way يا شباب, we may need to have help session to solve more problems. يعني I recommend to have يعني one help session at least يعني before of the midterm exam. So what do you think? طيب يعني please after finishing our class today we can arrange the time together. طيب. So this problem now, can please Malik, can you start solving with me, Malik? Malik, you hear me?
Yes, doctor.
Yes,
Sorry.
please start solving with me. A factory takes 600 kilovolt ampere. Let's draw together like a schematic in order to understand the problem. So we have factory that has some loads, and this factory has the main distribution panel. This is the source. So this is the source here, okay, or panel. And we installed a synchronous motor here. The aim of synchronous motor is to improve the power factor, as we discussed before. So here it's stated that a factory takes 600 kVA. So this 600 kVA is nothing but the load of the factory. So this is here 600 kVA. مظبوط كده؟ تمام يا مالك؟
Yes.
With a lagging power factor of 0.6, so power factor here is 0.6 lag. This is the load requirements. When the motor is taking 200 kilowatts, لا سوري, يبقى كده الكلام ده مش مظبوط اللي احنا عملناه هنا. هو بيقول لك in a synchronous motor is to be installed to raise the power. ولا انا قريت سطر غلط؟ سوري تاني يا جماعه. A factory takes 600 kVA at lagging power factor of 0.6. خلاص دي كده الملحوظه الاولانيه. يبقى ده عندنا اللود بياخد الكلام ده. بعد كده a synchronous motor is to be installed to raise the power factor to 0.9. يبقى after installing the synchronous motor, the desired value of power factor to be 0.9. So 0.9 power factor should be power factor at the source or at the load.
دكتور سوري, اول شيء كان 0.6 هو desired 0.9.
جميل.
ولا
ايوه صح مظبوط.
Okay.
So the desired here should be for source, صح ولا غلط؟
Yes.
تمام, because the load يا شباب is constant. Load cannot be changed, صح ولا غلط؟ This is the load. The load is the customer. يعني in order to improve the power factor you shouldn't ask customers to shut down some loads. It's not possible. يعني supplying loads is the target. Improving the power factor is developing. Okay? So in order to develop you have to consider all of the targets first. صح ولا غلط؟ يعني we cannot shut down loads in order to improve power factor. This is not an engineering solution. So the solution is to improve the power factor to 0.9. So we need the power factor now here to be 0.9, and considering that the motor has 200 kilowatts. So this motor is already working and has a certain load. Okay. Calculate the corresponding apparent power in kVA taken by the motor, taken by the motor and the power factor at which it operates. So what we need now, we need to calculate the apparent power here and the power factor of the synchronous motor. ها شباب, do you think this problem now is synchronous machine problem or just regular circuit problem?
Regular circuit.
It's regular circuit problem. يعني I think you are familiar with this kind of problems, but يعني just to refresh your knowledge, we will continue solving this problem. how we can يا شباب start analyzing and solve this problem. We have load or two loads, okay? One is given, which is 600 kVA, 0.6 power factor lagging. One of them we have P and power factor and SR unknown, and total power factor is given as 0.9. So how we can solve this problem?
First, we find the current in the load.
Current of which load?
The first one, right.
طب what we need? Malik speaking or who?
No, عادل.
لا ثواني عادل، يعني خلينا ماشيين بالايه بالاسماء. مالك بليز. يعني عادل suggest to get current. Do you think يعني it's the right start or not? You are not sure?
I think we can get the current, but I'm not sure really. But there might be another way.
ما فيش مشكلة. يعني هو الشور يا شباب، يعني can start solving with me now. ها؟ Nobody is sure about the. It's circuit.
Yes, we start from. We have the voltage and the current.
Voltage, where is the voltage? Voltage is not given, by the way.
600 key. Oh, so, okay. I thought it is current.
We have power. طب let's analyze the loads يا شباب. يعني we have load number 1. يعني assume that this is load number 1 now, which is the factory. Okay, before of improving power factor. يعني assume this is as load number 1, synchronous motor as load number 2, and this is the total. Okay, so for load number 1 يا شباب, we have P, which is equals to 600 kVA multiplied by power factor. صح ولا غلط؟
Yes.
مش الباور عباره عن الابيرنت باور multiplied by power factor. So 6 by 6 it's ايه؟ It will be 360 kilowatt. صح كده يا شباب؟ So Q1, which is inductive, so this is B1. Subscription 1 here يا شباب means load number 1. Okay? So Q1 means it's 600 multiplied by 0.8. صح ولا غلط؟ مش 0.6 cosine of the angle which has sine of 0.8. صح؟
Yes.
Which means we have here 480 kVAR. صح كده يا شباب؟ And this is inductive. We have to indicate that this is inductive. طيب. What about load number 2 يا شباب؟
Doctor?
تفضل.
I have a question. We take 600 600 from where, Doctor? Is it the 600 kilowatt or?
Yes, it's 600 kVA. It's given in the beginning. A factory takes 600 kVA. So this means that this is the factor load. Sorry, factory load. Okay.
Okay.
Which is considered as case number 1 or load number 1. تمام؟ For load number 2 يا شباب, which is the synchronous motor, we have only P. P is given as 200 kilowatts. Q is unknown, power factor is unknown. طيب. Regarding the overall power now يا شباب, what is the overall power? So we can say that for the source, yes.
The real power should be the total of the two.
We can say B total equals summation of the two powers, which is here 360 kilowatt plus 200 kilowatt. صح يا شباب? So we have now 560 kilowatt. This is the overall power. We have also the overall power factor is given 0.9. صح ولا غلط؟
Yes.
Can we get the amount of reactive power that should be delivered to the loads at 0.9?
Yes.
Yes,
it's stated that the overall power factor is 0.9. طبعا it has to be lagging, صح? This is the logic. 0.9 lagging. So if we have power factor is 0.9, how we can get Q? Let's draw the triangle together. Okay, we have here P, we have Q, we have S. صح كده يا شباب؟ And this is the angle of power factor. So we can say Q equals what? B multiplied by tan phi. صح ولا غلط؟
Yes.
What is the value of tan phi يا شباب؟ tan phi equals Q over P. صح ولا غلط؟
Q over P.
We can say here Q. طبعا we are speaking now about total. Q total and P total, and this is phi total. Okay. So we can say Q total now equals P total multiplied by tan angle phi, which is cosine inverse 0.9. صح ولا غلط شباب؟
Yes.
So we can say now the amount of Q total equals 560 multiplied by tan cosine inverse 0.9. حد يحسبها معانا كده يا شباب؟ What will be the value of Q?
271 kilovar.
Again, sorry, please, again.
271.
271.2
0.2
K var. طبعا this is inductive or capacitive يا شباب؟
Inductive.
Inductive. Which means this power, this reactive power, is supplied by the source. يعني it's going to from the source to load. طيب. Now we got the value of QT, which is here. And for sure, synchronous motor is used to supply reactive power. صح يا شباب؟ In order to improve the power factor. So now we can say Q2 equals overall Q or
Different.
Q1 minus Q total. صح كده يا شباب؟
Yes.
Yes.
So we can say now Q of synchronous motor, which is Q2 equal for synchronous motor, Q2 equals the value of 480 was 480 صح minus 271.2. مظبوط كده يا شباب؟ So this should be the value of reactive power. What is the value now يا شباب of Q2?
208.77.
جميل. طبعا this is K bar it has to be capacitive. صح ولا غلط؟ طيب. So we have now the value of Q. What is needed in the problem? We need to calculate the apparent power, صح? And power factor. So we can say now apparent power S of synchronous motor, which is S2, equals square root of 2 P square plus Q square. So it's nothing but 200 kilowatts square plus 208.77 square under square root of 2. This is going to give you the value of S. And finally, power factor of synchronous motor. Can anybody calculate the value of S?
289.11.
Sorry?
289.
289.1 kilovolt ampere. So now we can say شباب power factor equals B2 over S2, which is 200 kilowatts over 289.1. What will be the value now شباب?
0.69.
0.69. Lagging or leading? Lead, exactly, because it's supplying reactive power to it. Is it clear يا شباب؟
Now the Q will be positive or negative?
تاني again يعني positive or negative, it's according to the direction. يعني احنا based on our discussion we got the value first. يعني value of Q here, what we already obtained here, this Q is going to supply or moving from the synchronous machine to the surrounding loads. يعني on the figure here, if you would like to يعني show the direction, as you can see, this is the direction of Q. This is the direction of Q2 of synchronous motor. And the direction of the Q of our load, يعني it has to be in this direction. This is Q load, which is Q1. صح؟ يعني if you would like to make an equation now, follow the arouse of each Q. So we can say now يعني like Kirchhoff current law يا شباب Q2 plus Q total plus Q2 equals Q1 صح؟ If you would like to make يعني
Yes.
overall relation based on the directions as lagging or leading, you can say now يعني assume positive for lagging, so we can say now Q1 is positive, okay, Q2 is negative, Q total is positive. صح ولا غلط؟ يعني you can follow this يعني this rule also. طيب يعني يعني انا مش عايز بس يبقى في confusion في حته الاشارات. But if you understand the meaning, يعني synchronous motor will deliver reactive power in order to support or to improve the power factor. So this means يعني the value of Q2 has to be injected like that to this node. تمام؟ طيب.
دكتور.
اتفضل.
We said that Q2 is capacitive because it's motor.
لا, because we would like to improve the power factor, and in order to improve it has to be leading. صح ولا غلط؟
Okay.
For that يعني it has to be capacitive. Okay, I will leave يا شباب problem number 4 يعني for you. Please يعني also يعني think about it and we will discuss it later together. We will see your answers. Now يعني I will just hint for one of the ideas of the synchronous machine problems in the second file here, part 2. We discussed before شباب the voltage regulation. This is the relation of voltage regulation. We may need it in problems. Example number, let's focus now in example number 2 and later we can solve the previous one. We have here synchronous generator of 2200 volts. So this is now the terminal volt, and the current was 220 ampere. XS equals 8 ohm. If the excitation voltage is 220 volt, find the machine power angle. So number 1 here, we need to calculate delta شباب. طيب, now you have the value of EF, you have the value of V terminal, value of current, and value of XS. How we can get EF يا شباب? In order to get EF, you know the relation EF equals V terminal plus or minus up to generator or motor, صح? JIAXS. Here it's stated that it's synchronous generator, so we can select a plus sign. ماشي? We have طبعا in terms of angles, we have EF as a magnitude, so if we assume that this is line value, we can say now 2200 over square root of 3 at angle delta, it's not given, equals V terminal, which is the same value, 2200 over square root of 3 at angle 0, plus JXS. XS is given as 8, so J8 multiplied by 220 ampere at angle, power factor is not given, so at angle phi is unknown. So how we can solve this equation to get delta? It's impossible. صح ولا غلط شباب؟ In order to solve,
we use the other equation.
اتفضل.
We use other equation.
Which equation we have?
The power equal EV over X.
Do we have power?
Okay, yes.
It's not given also. صح؟ يعني you are right, we should think in all of directions in order to see how we can solve such kind of problems. However, if you could see, we don't have even the value of power. طيب, طبعا يا شباب complex number can be extracted into 2 equations. يعني one equation in complex number can be extracted in 2 different equations. One for real part and another for imaginary part. تمام? So this can be used as يعني a start for this solution because we have here 2 unknowns which are delta and phi. صح كده يا شباب? So if we extracted the real and the imaginary part, we may reach to finally to have two equations, and by solving these two equations together we can get the value. However, there is a much easier way. Instead of make it analytically, we can make it graphically يا شباب. يعني we have the value of V terminal. Let's assume to have a certain scale. Okay, for instance, assume we have 100 volt equals or corresponding to 1 centimeter, and we have the value of V terminal. So get the corresponding V terminal in centimeters, and start drawing the first vector V terminal. And you have EF with the same value, so you can use your tools to draw the locus of EF, which has the same value. So this line here, this is considered as locus for EF. طبعا يعني if the EF has different value يا شباب, يعني we can use the same way, okay, with different value. تمام؟ يعني باستخدام البرجل تقدر تفتح البرجل بأي قيمة أنت عايزها وترسمها. يعني here يعني we have the same two values, so we use the same value of V terminal to draw the locus of EF. طيب. But at which point EF will be, we don't know now, because we don't know exactly the angle of delta. طيب. Then we have the value of IA and XS. IA is given 220, XS is given at 8 ohms. So we can get the value of vector, which is GIAXS. We can get the angle, the magnitude, which is IA multiplied by XS equals 220 ampere multiplied by 8 ohms, which will give you certain voltage value. Use the same scale and start drawing the locus for this vector, which should start from V terminal and will intersect with the locus of EF. So by this way, Shabab, you will find this point is the point of intersection, and this, in this case, this will be the vector of EF, and this will be the vector of IAXS. So easily, now you can measure the angle here, which will represent delta, and also you have GIAXS, so you now know exactly the direction of IA. So IA will be in that direction, so this is a vector of IA now, and this will be the angle of power factor. So this is Shabab, a very simple way to solve this problem instead of analytical solution. Please solve this problem into scale on papers, and if you have any problem, let's discuss it again inshallah next class. Any questions, Shabab? Everything is clear?
Inshallah.
All right, here inshallah.
The session, Doctor.
Okay, and let's stopping our record, and we can start in our discussions.